Hello, we're beginning chapter 20, Aldehydes and Ketones. The thing I like about the Klein's textbook is that right in the beginning of each chapter, it tells you what to review. They suggest to review chapter 13, section 6, which involves Grignard reagents. They also suggest you review section 1310, which specifically talks about the oxidation of alcohols. Alcohols can be oxidized to form aldehydes and ketones. So definitely review PCC and the Jones reagent. Also, they suggest to review retrosynthetic analysis. We're going to begin to be talking about very large molecules and much more intricate carbon-carbon bond forming reactions. So definitely review section 12.5. And remember, retrosynthesis is the backwards thinking or breaking down of a molecule into more simple parts. Okay, so section 20.1 introduces aldehydes and ketones. And so here's some examples that are given to us in the textbook here. We've got vanillin. This is an ether, it's a phenol, it's an aldehyde. And the aldehyde is highlighted here in red. I should note that we normally do not show hydrogens that are bonded directly to a carbon atom unless they're very special in some way. The aldehydic hydrogen is always shown when we draw a line drawing of an aldehyde, okay? So that's the CH group. It's not acidic. We won't do much with it, but that hydrogen is traditionally drawn. We can also abbreviate this as a CHO. So if you ever see something written CHO, that means a carbon that's doubly bonded to the oxygen, and then you have a hydrogen bonded to the carbon atom. This next molecule is cinnamaldehyde. That's, of course, in cinnamon. And so here's the aldehyde functional group. This molecule is also an aromatic molecule, and it's also an alkene. Okay, it's a conjugated alkene. Carvone is here. This is a ketone. It's actually a conjugated ketone. You have a ketone, and then you have a double bond in conjugation, and then an isolated double bond way over on the left there. And it's chiral. All right, that's found in spearmint, chewing gum, for example. Benzaldehyde is responsible for the almond flavor. Okay, and so here is the aldehyde functional group, and it's aromatic. So remember, that's the very common structure of an aromatic ring with a aldehyde group attached to it. Progesterone here is the sex-female hormone, and it has two ketones. There's one on the upper right-hand corner, and then there's one on the lower left corner, okay? So we could call this a diketone, and you can see how the name ends in "one" here. Normally, if something ends in "one," it's going to be a ketone. Testosterone is the male sex hormone, and there's a ketone on the bottom left corner here, and that's the ketone group of this very large molecule. Okay. Now, there are very simple, very industrially important molecules that you should memorize. This right here is called formaldehyde. It's sometimes very simply written as CH2O if it's above a reaction arrow, for example, okay? Acetone is technically 2-propanone. We rarely ever call it that. Acetone is used for cleaning glassware in the lab, so you might encounter it there. It's nail polish remover, so you might encounter it at the nail salon. It's this very simple ketone. It's the simplest ketone, so you just need to memorize that name, acetone, and memorize formaldehyde. So that's it for types of ketones and aldehydes. We're going to get much deeper into this starting with the next video where we name aldehydes and ketones. Thanks for watching.